Hello and welcome to this section on discriminant analysis. In this section, we are going to take a look at how to carry out discriminant analysis with R, followed by model interpretation, and then how to do visualization, and we end this section with model assessment. So let's get started with the discriminant analysis with R. In this video, we are going to take a look at how to use iris data and make scatter plots and find correlations, and then how do we do data partitioning, and finally how do we carry out linear discriminant analysis. So note that this iris data is part of the R package, so we can recall this data just by saying iris within data. So if I type iris and run this line, that data is ready. If you want to look at the structure of the data, we can say str and iris. So note that this is a data frame with 150 observations and it has 5 variables. First 4 variables are numeric and the last one, which is species, is a factor variable and has 3 different levels. So let's make a scatter plot. We'll make use of library called psych, and there's a function called pairs dot panels. So we'll use this iris data, and as you know, we cannot make a scatter plot for factor variables, so I'm going to use only first 4 variables, and for that I can use this square bracket and say 1:4. So it will only include first, second, third, fourth variables and ignore fifth one. I'll also include some more features here. So let's say gap between the scatter plots is 0, and I also want to use different color for the 3 different species by saying C, and let's have colors as red, green, and maybe blue. We can also specify that these colors are for iris, $, species. I can also choose a plot character, so I'll go with number 21. So now we can run this and get the output in the 4th window. So this is what we get. You can see all the 4 numeric variables are listed here. We see histograms and we also see the scatter plots. And if you look at petal length versus petal width, so this scatter plot, you can see there is a good linear pattern and correlation coefficient which lies between -1 and +1. So this number is very close to 1. So correlation between these 2 variables is linear and it is also quite high. If you look at these different colors for the 3 species, you can see that there is a species which is away from the other 2, and then there is some overlap between 2 species like blue and green here, and the red one is quite away. So the idea here is how can we find linear combination of these 4 variables that will give us the best possible separation between these 3 species. So that's what we plan to achieve by doing linear discriminant analysis. So before we do that, let's do data partitioning. So I'm going to use a set.seed of, let's say, 2 to 2, so that the data I get in training and testing are same as your data when you use seed of 2 to 2. If you use some other seed number, then our data may not match. So this is just for repeatability. So let's store independent samples in IND, and I'm going to take a sample of size 2 and row for iris, and this is a sampling with replacement. So for replace I will say true, and probability is, let's say we want 70% for the training and 30% for the testing. So if we run this and then we can say training, is iris, and within square brackets we can use IND that we created, and we say whenever it is equal to 1. So remember, for equal we use two equal signs. So whenever it is equal to 1, so that's what we want, and after comma we just leave it blank. So we run this, and you can see training data set has 101 observations out of 150. So for testing we have 49 observations. So we have created training and testing data, and now we are ready to do linear discriminant analysis. So for this, the library that we need is called MASS. So note that if you have not downloaded this library, you may have to download this. So you have to go to packages, click on install, and then use MASS. So since I already downloaded this, I'm not going to do it. I can simply run this library and the package is ready. So now to do linear discriminant analysis, I'm going to use this LDA function. It's called linear discriminant analysis. And the way we use this is very simple. So our dependent variable is species, and we want to say this is a function of with the tilde sign, and then we can put dot. So dot will mean that all other variables. So in this case we have 4 numeric variables. So all of them will be included in the model. And then we can specify what is the data that we are using. So we are going to make model based on training data. And let's store this in linear, because this is a linear model. So I'm just using this name here. So as soon as you run this, R has created a linear discriminant analysis model,